Okay, so this is part 2 from the review. So let's do it. At a girls' volleyball game, the student council officers sold hot dogs for $1.50. So let's keep in mind that. Hamburgers were $1.75. So we got hot dogs and hamburgers. They sold 25 more hot dogs than hamburgers. My coaching advice is whatever they list second, you call X, and whatever comes first is your comparison statement. So that would be 25 more. So they have X number of hamburgers sold, X plus 25 hot dogs sold. So there's your variables. What's the equation? Well, if the hamburgers are $1.75 each, that'd be $1.75 per hamburger, plus the hot dogs were $1.50, but this is how many we sold, so that'd be X plus 25, and the sales are $118.75. So there's the equation. Now we just have to solve it. So I'm going to distribute, so I get 1.75x plus $1.50 per hot dog, plus, I'm going to go ahead and use this, 25 times 1.5 essentially, 3750 equals 118.75. So I'm going to go ahead and subtract this from this side. I'm going to subtract it from that side. So 118.75 minus 3750, 81.25. And then I add these together, and I'm going to get 3.25x. So I'm going to divide by 3.25, divide by 3.25. Pray for a whole number, because when you're doing these types of story problems, you're not going to have partial hot dogs or hamburgers. So that's 25. Remember what X is. X is how many hamburgers. And so then it says, way towards the bottom, how many hot dogs, how many hamburgers. So we know there's 25 hamburgers. So they sold 25 more hot dogs. So we just have to add 25 to that. So that would be 50. All right, so here we go. Number 20. If one side of a square is increased by 3, so we better stop right there. So here's a square. All sides are the same. And it says if one of the sides is increased, so we're going to take this one, we're going to draw it longer and say that's increased by 3. In the adjacent side, that just means the next two, is decreased by 4, so we'll make this shorter. It's not perfect, but a rectangle is formed, so we know that here's our rectangle. If that's x plus 3, this is x plus 3, and if this is x minus 4, then this has to be x minus 4. Write the equation needed to find one side of the original square, and it's saying if the perimeter of this new rectangle is 46. So I'm going to take this, x plus 3, I'm going to take this, x plus 3, I'm going to take this, x minus 4, and I'm going to take this, x minus 4. I'm going to set that equal to the perimeter, and there it is. All they wanted was the equation. They didn't even ask us to find anything, but if you actually solved, you could find x, which if they asked you for the dimension of the rectangle, you could find it, or the square. So, but they didn't, so let's move on. Number 21, a piggy bank contains 50 coins. That's significant, consisting of dimes and quarters. So we'll just call this X. I'm just going to call quarters X. And if there's 50 total coins, then the number of dimes would be 50 minus X. So if there's 10 quarters, there's 40 dimes. If there's 25 quarters, there's 25 dimes. If there's 40 quarters, there's 10 dimes. But this is how you represent it mathematically. So I know a quarter is 25 cents per quarter. I know a dime is 10 cents for every dime. And the total value is $9.20. So here we go. This times this is just 5. This times this would be negative 0.10x plus 0.25x equals 920. I'm going to go ahead and subtract 5. I'm also going to add these together. So I get 0.15x from this equals 420. Divide by 0.15, divide by 0.15. Let's see what this spits out. 420 divided by 0.15. 20. Something happened there. 420. I didn't notice it. Divided by 0.15. There we go. 28. So we got 28, whatever x is. What did we say x was? The number of quarters. And so they're asking how many of each kind of coin is there. So we know there's 50 minus x dimes. So that's 50 minus 28. And that'd be 22 dimes. There's our two answers. Last problem, you guys. So Ashley has an annual return of $243 from $5,000 invested at simple interest. Some at 3%, the rest at 6%. So let's just say that out of this $5,000, we're going to take X number of dollars and pour it into that 6% interest. Well, that means whatever's left over will be pumped into the 3%. So I'd have to take the total amount, 5,000, and subtract whatever I put into the 6%, and that's how much I ended up putting in the 3%. And here comes the equation. So 6% is 0.06 times the amount I put into that plus 3% return times however much I put into it. I got to put parentheses around this. So that's whatever's left over after I put the money into here. And it says my annual, which means yearly, return is $243. Not a ton of money, but better than nothing, I guess. So I get 0.06x. This times this, I do not want to make a silly mistake. 150 minus 0.03x equals 243. I'm going to add these like terms together, so I get 0.03x. I'm going to subtract 150, so that's gone. Subtract 150, and that'd be 3, 9. There we go. Divide by 0.03, gone. Divide by 0.03. So I get 93 divided by 0.03. 3,100. So x equals 3,100. But let's go back to the question. How much is invested at each rate? Well, 3,100 is my x. That's how much I decided to put into my 6%. So that's at 6% interest. And whatever's left over is at my 3%. Well, if I have 5,000 and 3,100 of it went into here, that means 1,900. The rest has to go into the 3%. That finishes part 2 of this chapter review. Good luck.